So, the cells are usually organized, okay, there may be many cells like this, and these are BL and BL bar, and they are sort of connected like this. So, if I wanted, let us say, a 8 cross 1 1 2 0 1 2 3 4 5 6 7. So, this is a 8 cross 1 SRAM. Remember, there are word lines which I have not shown here. So, there are word lines here. We can call them WL0, WL1, WL2, WL3, WL4, WL. Oh, sorry. So, there is a WL0, WL1, WL2, WL3, WL4, WL5, WL6, and WL7. So, when we access any one of these cells, we will need what is called as a decoder. So, we will need a 3 to 8 decoder. So, these 3 inputs are called as the address. So, if I want to read or write from into cell number 0, I will put 000 here. So, it will activate WL0, all others are deactivated. And if I want to read, I will apply both BL and BL bar equal to 1, and there is a sense amplifier here, which recognizes the small change in potential in BL and BL bar, and based on that it is able to tell whether the cell contains a 1 or a 0. So, it provides the data output. In the same way, if we want to write a 1, we have to produce BL, I think this is BL bar and this is 1 BL. This is BL and this is BL bar. So, the decoder helps us in selecting the cell which we want to read. So, there are many, in this example 8 word lines. So, this will, from an outsider's perspective or a black box perspective, this looks like there are 3 address lines and then there is a data output, and if you have to write data input, you will have to have a D in input data, and then there is a control signal which says either read or write. So, it could be read bar or write. If it is 0, it is read. If it is 1, it is write. So, this is what an SRAM 8 cross 1 SRAM. So, the way it works is if I want to write into 4, I will make W equal to 1, A2, A1, A0 equal to 0, 0, 0, sorry 1, 0, 0, and internally the WL4 will be activated, all other WLs are 0, they are deactivated. And if you are reading, then B and BL bar are charged, pre-charged, and the sense amplifier senses the small change in the B and B bar lines and produces the data out. And the other way around, if we are trying to write, then we have to select BL to be 1, BL bar equal to 0, depending on whether we are trying to write a 1 or write a 0. So, that is managed by the internal circuitry of your RAM. So, all these are internal, this decoder, a sense amplifier. Imagine if we have a very large SRAM of many 1024 bytes or something like that. See, this linear organization will be very painful, right. So, if you have a, let us say 1024 by 1 SRAM, then organizing it linearly like this will be very difficult. So, instead what is done is they are organized as a 2-dimensional array. So, a 1024 bit SRAM will require 10 bits of address. A0 to A9. So, we can organize this as a 32 cross 32, it will be a square organization. We can organize it any way we want, it does not have to be square. So, if you organize it as 32, what you can do is you can have 2 decoders, one is called as the row decoder and the other is called as a column decoder. So, these will be A0 to A4 and these will be A5 to A9. And this decoder will have 32 wires and this will have 32 wires. So, if we have addressed, let us say, the all 0 pattern, then it will it will say that this is the row in which the memory cell is and this is the column in which the memory cell is. So, the corresponding word line will be activated, the word line for that particular. So, what we can do is we can have one word line for all of these guys. Okay, there will be many cells and they are all going to be selected by that same word line. So, A5 to A9 when they are 0 0 0 0 0, then this entire row of cells will be activated. But the column decoder helps me to select the particular column that we are looking for. So, we will read all of these guys, but then select only this guy. So, sometimes this is a column select. This is a better organization, more efficient than some sort of a linear organization like this. It will be very clumsy to sort of maintain something like this. So, looking at all the things that are there in a RAM, we have the cell array, that is this guy. We have the decoders, row and column decoders. So, this is a row decoder, this is a column decoder. We may have sense amplifiers. So, I have not shown that explicitly, but it will be here. Then, so these are some of the things that are there in a memory cell or the memory in SRAM. Notice that so many things can go wrong, right? Maybe a word line is open, two word lines are shorted, the address decoder has a fault, right? The address decoder fault may cause multiple lines to become one. It is supposed to select only one word line, but it may activate multiple word lines or two word lines. Or maybe some cell has a problem. Okay, it is not, it is stuck at a particular value. We are not able to write whatever we want into it. Okay. So, there are many faults can occur. In an SRAM memory. And given that the size of the SRAMs is so high, right, like I said today its SRAMs are very large in size. They may have several megabits in one SRAM. So, trying to deal with defects like this and faults like this will be very difficult. Okay. So, the people who worked on memory testing, they said we cannot deal with so many different faults, right, and we cannot do what is called as white box testing. So, if I give you all the details of the memory and say test it for me, it is not going to be easy. So, instead they perform what is called as functional test. which is like a black box. It treats the memory as a black box with some row address, column address, data input, data output. And then we can say there may be a read write control. Then we can say, hey, maybe we try to write a 1 and it does not write a 1 in that particular cell. Maybe we try to write a 0, but it does not write a 1. So, that is the kind of fault model we can develop. We cannot have this wire stuck at 1 or stuck at 0. Those kind of faults are not considered, because it is going to make it very complicated.